Hi, my name is Julia Majmundar, and this is my interactive advanced concept presentation to the clock reaction. The iodine clock experiment involves a series of reactions where colorless solutions suddenly turn blue, almost like a clock striking the hour, hence the name iodine clock. This dramatic color change occurs due to the formation of a blue-black complex between iodine and starch. There are different reactions involved in this experiment, and one is the production of iodine. I gave the breakdown of the elements, and in this reaction, iodide ions are oxidized by hydrogen peroxide in an acidic solution to produce iodine. Another reaction involved is iodine reduction. Here, any iodine produced in the first reaction is immediately reduced back to iodide ions by sodium thiosulfate until thiosulfate is depleted. Once all the thiosulfate is consumed, iodine accumulates in the solution. The iodine then reacts with starch to form the blue-black starch iodine complex, and this is mine from my experiment. So there are quite a few materials that I needed for this experiment. I needed vitamin C tablets, iodine tincture, distilled water, used a lot, cornstarch, which is over there, iodine tincture until the color disappeared. The iodine reacts with vitamin C, getting reduced to iodide ions. This reaction consumes the colored iodine molecules, and then I topped the solution up to 500 milliliters with distilled water. And then after that, we had to prepare the solution B, and that's the oxidizing agent and indicator. I mixed cornstarch with 350 milliliters of water, and the starch will act as an indicator, forming the blue-black complex with the iodine when it reacts. I heated the mixture in the microwave until the water started to boil, and then I filtered it so that it would be more clear. This step helps dissolve the starch for a clearer solution. And then I added 150 milliliters of hydrogen peroxide, and I mixed well. Hydrogen peroxide is an oxidizing agent accepting electrons. It will slowly oxidize iodide ions back into iodine. Then I started to mix the solutions. I combined equal amounts of solution A and solution B in in this cup. And then I observed the sudden color change after some time. In my experiment, it truly was some time. I actually gave up on 2 solutions before, and I thought it wasn't going to work. But then I tried for a third time, and I mixed, and I waited, and it turned, and I was so surprised. And then the beaker that had the solutions that I thought weren't going to react, did react over to the side, and it was so cool. The chemistry behind that is vitamin C initially prevents the color change by rapidly reducing any iodine formed. Once vitamin C is depleted, the reaction between iodine and starch creates the blue-black complex. There are 2 competing reactions. Reaction 1 is vitamin C, which is absorbic acid, plus iodine goes into dehydroascorbic acid with iodide ions. And then the reaction 2 is hydrogen peroxide plus iodide ions, and that leads to iodine and water. The clock is the time it takes for the color change, and it indicates how long it took for the vitamin C to be consumed. There are different factors that can affect reaction time. One is concentration. Higher concentrations mean faster reactions and shorter clock times. Temperature, when the temperature is increased, it can speed up the reaction, as well as the presence of catalysts. Catalysts can also speed up the reaction. In conclusion, the iodine clock reaction is often used to illustrate chemical kinetics and reaction rates in educational settings, or in research to study the effects of various factors on reaction rates. Thank you.